at point number 1 is 300 Kelvin. But this time, we don't know the specific value in characteristic nodal point. We know the ratios, yes, between, for example, P2 and P1 and V3 and V2, okay? So, what we have to do, present the circuits on the both diagrams, okay? Mark work and heat inlet and outlet. But to do this, at first, we should calculate the temperatures, exactly. And how to solve this. Once more paint cut. I think it's that. No, it's not that. The second one. Okay. So look, what we know. We know that we have isentropic transformation. Yes. Isobaric 1. Isentropic, isobaric, isotherm, and once more isobaric. Yes. We know only that the temperature here is 300 Kelvin. Yes. And we know that the pressure between nodal point number 2 and 1 is 10, and between the specific volumes between 3 and 2 is 5. Okay, that we know. So, at first, I will take the isentropic process under consideration between 1 and 2. And I can draw the formula for this transformation like that. Yes, standard transformation equation. Okay, and here I will calculate the temperature at nodal point number 2. Yes, it is temperature at 1, P2 to P1, kappa minus 1 to kappa. Finally, the temperature at nodal point number 2 is 531 Kelvin. Okay, we know that. Then, between 2 and 3, we have isobaric transformation. Yes? So, we know that V2 to T2 is the same as V3 to T3. Okay? And we can calculate the temperature at nodal point 3. Oh, it's quite huge temperature. It's over 2500, so really great temperature. Then we know that between 3 and 4, it's isothermic transformation. Yes. So the temperature at nodal point 4 have to be the same as at nodal point 3, like that. Okay. So now we know the temperatures. Yes. We know the 4 transformations, and we can prepare the TS diagram. Okay. The lowest temperature is at point number 1. Then we have isentropic transformation. So the temperature increased to nodal point number 2. like that. Okay. Then we have isobaric. So the isentropic, the temperature increased to point number 3. Then it is isothermal transformation. So the temperature is constant to 4, and back to another point number 1. Yes? Yes. The same, the same in the PV diagram will look like that. Okay? From from another point number 1, the pressure increased to point number 2. Look, uh, P2 to P1 is 10. Okay? What does it mean? That this the pressure 2 is 10 P1. Okay? It have to be greater. Then we know that between 2 and 3 we have isobaric process. Okay? Then isotherm. So down, and one again isobaric process. So back to another point number 1. Okay? Of course, the same situation like in task number 1. This is our LA, absolute work, but here you have to be very careful, okay? Because look, everything what is under the higher curves, okay? Here between 2 and 3 and 3 and 4, yes, this, it is Q input, okay? So it is not always the, we have not all the time the situation that the Q input is between 2 and 3 and 4. No, it could be between 2 transformations, 4 transformations, okay? And the same situation is with the Q output. Here it is very simple because Q output is between 1 and 4, okay? But when we have transformation not like that, but like that, no, not like that, that, okay, that here we will have, for example, isobaric process, yes, like that, and once more isothermic, so 4, 5, and 1, okay, the Q output, it will be the area under the curves between 4, 5, and 1. So here you have to be very mm, mm, very careful about the Q input and Q output, okay? But when we know, we can calculate. So at first, we know that Q input is between 2 and 3 and 3 and 4, yes? So we know that the Q input is it is at isobaric process and isothermal process, okay? So Q input, it is the sum of Q in 2, 3 plus Q in 3, 4. Yes. For the to 3. Yes, for the isobaric process, it is kappa to kappa minus 1 m r to m. It is r. Yes, the same r, r. Okay, and this is Cp. Yes, everything multiplied by the difference of the temperature, and then between 3 and 4, my dear students, between 3, yes, and 4, we have isothermal process, okay? And we know that in isothermal process, P3 V3 logarithm V4 to V3. It is the same, okay, as P3 to P4, the same, because it's isothermal process. So V4 to V3 is the same as P3 to P4. And then look, because I don't know the parameters of pressure and volume, yes, I want to write this with the temperature. So I use the P3 V3, it is M R T3, correct? And yes, and look, because we are doing the calculation for no for at specific values, so per 1